about Z, and then you have the next moment this is your moment about Y. Okay, so I'm going to shift the moment about Y to over here, right? So like what I've taught you before, if you look at moment about Z, right? So right hand rule, right? The thumb is the arrow, and then how you grip. So this is your MZ, right? So on MZ over here will be tensile. Head of the arrow will be what? Compression. On MY, right hand rule again, you have this, right? So on MY, right, over here will be compression. And over here will be tensile. Nothing changes. Okay, nothing changes. Our analysis is still the same. Only now you have two components. So in that case, that they call it unsymmetrical. And I'm going to prove to you why unsymmetrical. So from here, we know, so we have to break them down to components, right? You know the my. So we know the my. Okay. My is equal to m sine theta. Okay. And we also know that mz is equal to m cos theta. Right? We know that my is m sine theta. Mz is going to be m cos theta. So for this case, when it's unsymmetrical bending, now your formula changes. Not changes. Additional things come in. So you have this. So stress X is equal to mz or my over Iyy multiplied by z, then plus by mz over Izz multiplied by y. So this is the formula that we will use for unsymmetrical loading. Okay, so this is the formula that we'll use for unsymmetrical centric loading. Okay, so now I'm going to show you why unsymmetrical. Okay, so I'm going to draw our beam. Okay, in the view. So now this is my y. This will be my z. Rotation about x. Okay. So this is our view, right? And then we have our my. So my is in this wrong color. Sorry. So my is in this direction, right? So this is my. So right hand rule, right? Your thumb points up how you grip your structure. So this will be compression. This will be tensile. And then you have the other moment vector. This will be your mz. Okay, then you grip. So over here will be compression. Down here will be tensile. Okay. So I'm going to call this point H I J and K. Okay. So we are going to look at points. Okay. So stress X at point H, stress X I, stress X J, and stress X K. Okay. So the first term that we have that we're going to use is we're going to use our my over Iyy z. Okay, so that's on one column. And then the next one, we're going to have our mz over izz multiplied by y. Okay. So if you look at point H, okay, we're going to look at point H first, right? If we look at point H, the moment about y will generate tensile, right? So this will be positive. The moment about z will induce what? So you look at point H, right? You look at point H, right? My will be tensile and mz will be compression. So this will become what? Negative. Next, we look at H, right? My will be what? Compression. Then mz will also be what? Compression. And then if we were to look at J, right? So if you look at my will be what? The J due to my will be tension. So this will be positive. And then based on mz will also be what? Tension. Right? And then if you look at K, okay, if you look at K, right? K my will be what? Will be in the negative. And then the K will also be what? Will also be in tension. Yes or no? So the K will also be in tension. So if it's symmetry, or symmetrical loading, right? Stress X at point H must be equal to stress X at point I, and stress X at point J must be equal to stress X at point K. Are they equal? Anyone? So for this case, what you see over here, right, is unsymmetrical. Because stress X at point H is not equal to stress X at point I, or stress X at point J is not equal to stress X at point K. And, okay, and, I'll write this down, and, right, even we compare stress X at point I is also not equal to stress X at point J, and stress X at point I is not equal to stress X at point K. So that is why we call this type of loading unsymmetrical loading. Only for that reason. Okay. So a thing that you have to be really, really careful. Okay, I'll elaborate. Okay. Is this formula over here that you have to be, or this formula over here, you have to be really, really careful. And this formula, you are really, really careful. Why? Okay. So if we look at my over Iyy z, so we're going to draw our usual block.
Eugene,
Yes.
so how did we determine that those two pairs are not equal just by looking at the signs?
Yeah.
And magnitude also.
Yeah, magnitude also. So positive, negative, 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 positive, positive, negative, positive. There's no way they'll be the same.
Yeah, the signs are different.
Yeah. Yeah, so when the signs are different already, it will tell you that the magnitude will also be different, right?
Yeah, even if they're same, because the signs are negative, it will never be the same.
Yeah, will never. Let's say the left column and the right column both are 10, right? But one is positive 10, the other one is my negative 10, will never be the same, right?
Exactly. Okay.
Yeah, there you go. Okay. So if this is, we look at MZ, okay, MZ. So the next thing that a lot of people, or MY, a lot of people make mistakes is, so we're looking at MY over IYY Z, right? So MY, so this is your moment Y, right? So if this is your moment Y, right, this is your moment Y, your moment Y is over here. And then you're going to look into your YY axis, right? So this is your YY axis, right? So this is your YY axis. You have to remember that this is your what? Width. And this is your what? Depth. Like what I told you before. The geometry that's parallel to the axis of interest is your width, perpendicular is your depth. Like how I tell you. And you also have to remember, okay, this position over here, this direction is your Z. So this is the Z that we're talking about in terms of geometry. So a lot of times students get really confused. Even I got confused until the past 5 years. Then I'm fine. And then if we look at MZ over IZZ multiplied by Y, a lot of times again you have to be really careful with this. All right, you have to be really. So now we are looking at where? We are looking at So this is your MZ, right? And the axis of interest is going to be your ZZ axis, right? So this is your ZZ axis. So now you have to remember parallel this will be your width. Perpendicular will be your what? Will be your depth. Okay. And now the Y distance is in this direction. That is Y correspond this Y, this Z. So that's where a lot of times a lot of students get confused. But guess what? Did I teach you anything new? The answer is no. We still apply what we learned, right, last week in symmetrical loading, right? Over here is still the same, right? Like this is what we have applied. What is the width and what is the depth? Nothing changed. Name is different. More components to analyze. The foundation is still the what? The same. Okay. Go for a 15 minutes break. Oh, you know what? I did. Sorry. Go for a 15 minutes break. We come back at 8:20 and we carry on. Okay. I thought I did not record.